Rectification is the conversion of an alternating current into a direct current. This involves a device that only allows one-way flow of electric charge. Let's understand how alternating current works. Through Faraday's law, when the magnetic field cuts the coil, there is an induction of electromotive force. Electrons exist in a conductor. If voltage is applied to the conductor, they will flow. Hence, they are responsible for the current flow. Let's assume these spheres are electrons. When a magnetic field cuts the conductor, they move through the conductor. Remember, the magnetic field strength of a magnet is stronger at the poles. So when the south pole approaches, the electrons will gradually increase their motion from less to maximum when the south pole is on the coil, and then decreases again when the south pole has passed and moving away. Similarly, when the north pole of a magnet approaches, the electron's flow will increase gradually, then decrease gradually as the pole moves away. But this time round the direction of the current reverses. So when we plot these values, we will form a sinusoidal waveform, with forward current plotted at the positive half and the reverse current plotted at the negative half. Also, something to note is that when the magnetic field cuts the coil with both its south and north pole, we will form one revolution, and this is what we called frequency. When frequency of a phase is 50 Hz, it means it gone 50 revolutions within 1 second. Similarly, if it is 60 Hz, it means it has gone 60 revolution per second. In regards to the formula T equal to 1 over frequency. Similarly, if we have three-phase electricity, the waveform will occur in a similar manner but displaced in 120 degrees from each other. In general, this is called alternating current. On the other hand, the direct current just flow continuously in one direction, majorly from DC source such as battery. The aim of the rectification is to convert this AC current to a pure DC current. In the circuit, if we place the diode, it will block half of the waveform. Remember, diodes only allow current to flow in one direction. For example, forward current passes and reverse current is blocked. We will get a delayed direct current flowing in one direction. As we can see, during the positive half cycle, the current flows, and during the negative half cycle, the current is blocked. And the diode is allowing this to happen 30 times, allowing current, and 30 times, blocking current in 1 second for 60 Hz frequency. This is a pulsating DC current. If we achieve this DC current with one diode, which is responsible for current blockage, this is what we called half-wave rectification. In half-wave rectification, during positive half cycle of the AC sine wave, the diode is forward biased, since the anode is positive with respect to the cathode, resulting in current flowing through the diode. While the output of a rectifier is a pulsating DC, most electronic circuits require a substantially pure DC for proper operation. The pure DC output can be provided by a single or multi-section filter circuits placed between the output of the rectifier and the load. For example, using capacitor as a filter in circuit, the ripples will be reduced. Capacitors have the ability to store charges and release them to the load. Check our capacitor and diode videos on how they work, link in the description of this video. In general, filtering is accompanied by the use of capacitors, inductors, and resistors. Capacitors are used as shunt elements to bypass the alternating current around the load. Let's briefly review the properties of a capacitor. First, capacitor opposes any change in voltage. The opposition to a change is called capacitive reactance Xc and is measured in ohms. The capacitive reactance is determined by the frequency F of the applied voltage and the capacitance C of the capacitor. Therefore, Xc is equal to 1 over 2 pi Fc. From the formula, you can see that if frequency or capacitance is increased, Xc decreases. Therefore, filter capacitors are placed in parallel with load. The capacitor acts as a short circuit for the AC component in a ripple form of voltage. A low Xc will provide a smaller opposition to the AC component and thus better filtering than a high Xc. Therefore, to obtain the best possible filtering, the capacitor should be as large as possible. Another consideration is charging and discharging time of the capacitor. Should charge fast and discharge slowly. To obtain a steady DC outputs, the capacitor must charge almost instantaneously to the value of the applied voltage. I won't go to the RMS and peak value. Check our previous video. But in this half-wave rectifier, there is a very large gap. Therefore, we can improve our circuit instead of having one diode. We can use two diodes to block and allow current flow. With the help of a center tap transformer, we can see that both positive half cycles are formed in one frequency. This is what we called full-wave rectification. This is how two power diodes can be connected together to form a full-wave rectifier that converts AC voltage to pulsating DC. With the help of a center tap transformer, we can connect the diodes such that when one diode conducts current, the other one blocks the current. Similarly, when the other one allows current, the other diode blocks current. This type of rectifier circuit is called biphase rectifier circuit. We will receive pulsating DC with positive half cycles alone. Such that the frequency of the output will be 120 Hz instead of 60 Hz, and 100 Hz instead of 50 Hz. When we add some filtering capacitor, the output will be more improved DC with less ripples. Adding an inductor to such a circuit would reduce the ripples even further to form a pure DC output. Inductors are called passive components, similar to resistors and capacitors. The main function is to keep the current constant. Using inductor in the circuit, the main things that should be noted are: when current flow, the magnetic force is generated, and it has the property to easily pass direct current than alternating current. But instead of using a transformer in our circuit, we can use four diodes connected in a bridge way. As we can see, two diodes conduct current once, while the other diodes blocks. This type of circuit is called bridge rectifier circuit. Adding some capacitors and a voltage regulator will provide a very pure DC voltage. This is because a voltage regulator generates a fixed voltage of a preset magnitude that remains constant regardless of change to its input voltage or load conditions. Check how diode and capacitor works, link in the description. Like our Facebook page at Wired Wisdom Engineering, link in the first comment. I hope you found this video informative. If you did, kindly subscribe, like and share. See you in the next one.